So now in this video we are going to add and subtract fractions. And the last few videos we spent time talking about least common multiples, greatest common factors, and then last video we used those things to make what we called equivalent fractions and reduced fractions. Right? So what we're going to do in this video is use the least common multiple that we learned about in the last 2 videos ago, right? And we're going to make common denominators, which is actually something we did in last video. So if you haven't watched those, you can watch those to kind of get a preview of some of the important skills that we're going to need for this one. So you can see it's all kind of building on itself, right? So here's the summary. To add or subtract fractions, the denominators must match. Okay, that's what we call common denominators, when the denominators match. Okay, to make them match, we are going to look at the denominators, okay, of both of the fractions, or if there's 3 or 4 fractions, all of the fractions. And then we are going to find the least common multiple, and we're going to create equivalent fractions that use that number. So again, this will all be more clear once we do an example. But I really want to really quickly talk about why do the denominators have to match each other, right? So let's kind of go up, and we're going to do a little bit of a picture example. So I'm going to get myself, if you remember back to like the first time you ever learned about fractions, okay, what they did was they kind of gave you these like little pie charts. Okay, and they showed them to you. Just pretend like these are the same size. Not all that important. Okay. But what they showed you was that if I wanted to show a picture representation of a half, what I'd do is I'd kind of cut this into 2 regions, right? And if I wanted to show you 1/2, I would like shade in one of these regions and say this is a half, right? And if I wanted to show you a third, right, I would do the same thing. I would kind of cut this into 3 equal pieces, and it would look something like a peace sign. Okay, probably a little bit wider, but let's assume those are equal regions. And I would just shade one. I'd say here's 1/3, right? So if I wanted to do 1/2 and 1/3, hey, that's what it would look like. Right? The problem is that I can't, if I were to say let's add together this region and talk about like what is that, how much does that represent now? Well, I can't talk about that because they're different sized pieces of a whole, right? And so the idea is that if I can divide these pictures into kind of the same number of regions, then I can talk about it. And here's what I mean. Right? I can take 1/2 and say, well, if I do this, right, and I chop it up more, okay, now if I were to count, I have 1, 2, 3, 4, 5, 6 regions, and I've shaded in 3 of them, right? And I can do the same thing with thirds, and let me see if I can do this without messing it up. If I go like this and say extend this line out and extend this line out, right? Now this also has 1, 2, 3, 4, 5. Oop, I missed a line. Okay. Oh, there it is. Extend that line out. Okay. If I were to take this and say this now has 1, 2, 3, 4, 5, 6 regions, now I can compare them. I can say, well, 1/2 is 3 out of 6 regions, and 1/3 is 2 out of 6 regions. Well, now I can say total I have 5 out of 6 regions filled up. Like I could actually take this one and kind of put it here. Okay. And I can take this one and I can put it here and say, hey, look, 5 out of the 6 regions have been filled. Okay? So when we're adding and subtracting fractions, we need to have the pie cut into an equal number of pieces to do that. And that's what we mean by equivalent fractions, right? 1/2 meant the same thing. 1 out of 2 pieces of the pie meant the same thing as 3 out of 6 pieces of the pie, right? So that's the whole, kind of the whole goal of what we're getting at here, right? So I think it's important to see this and to understand it because your job's going to be to remember these rules, right? And instead of remembering rules, when do I need to add the denominators to match and when don't they? Okay, think about why you're doing this, right? The reason that you're finding common denominators is because I can't move the pieces of the pie together to add them unless they kind of represent the same size wedges, right? So let's go and take a look at our examples here. Okay, we're going to do a quick common denominator problem. Remember, the goal here is to kind of take this pie that's in thirds and make it into something that we can kind of shove sevenths into. All right? So I'm going to say 1/3 and 3/7. They need to have a common denominator. If you were to make a list of all the 3's, okay, here they are. 9, 12, 15, 18, 21. And I'm going to stop because I know that the list of 7's, okay, also has a 21 in it. 21 is the common denominator here. Okay, so I'm going to say 21. And this one also needs to have a 21. Right? So what we talked about in the last video is if I want equivalent fractions, in this case fractions that have 21s in them, when I turn this 3 into a 21, I did times 7, so I'm also going to do 1 times 7. Okay? And that's the idea. 7 over 21 represents the same pie, the same shaded part of the pie, but now there's 21 wedges instead of just 3. Okay? And I'm going to do the same thing with the 7 here. I'm going to say 7 turned into 21 by multiplying by 3. So I'm going to do 5 times 3 and get a 15. Okay? And I can do the same thing with these, but I'm going to look at these ones and say the list of 15s, I'll say 15, 30, just to show you a couple of them. The list of 5s, I'm going to say 5, 10, 15. There's your least common multiple. Okay? So now that I have that 15 is the least common multiple, I'm going to look at this and say, well, I did kind of 15 times 1. I didn't change anything, so this one's not going to change at all. This one is going to change because I want this to be a 15, because I'm saying common denominator. They need to be the same. So I did 5 times 15, so I'm also going to do 5 times 3, so I'm also going to do 3 times 3 and get a 9, right? So these are now fractions that have common denominators. Now I could consider, like, how do I put them together? All right, so here's your summary of adding and subtracting. All right, now that we can kind of find common denominators. Okay, to add or subtract fractions, you're going to find common denominators, means make all the denominators match, and then you're only going to add across the top. Okay, the numerators are the only thing that are going to get added. The denominator is going to stay the same. And I want to go back to this example and explain why. Okay, in this example, okay, I actually, if I was kind of saying what's 1/2 plus 1/3, well, our answer ended up being 5/6, right? So the way that ended up happening was once we split this up into 6 pieces, we ended up with 3 out of the 6 pieces being shaded. And when I split this up into 6 pieces, 2 out of the 6 pieces got shaded. So really what we're claiming when we're doing adding and subtracting is, okay, there are going to be 5 wedges out of 6 being, filling up this pie when I add together the shaded parts. The denominator is not going to be the same because our pie is not changing. We're still talking about a pie that has 6 pieces in it. But I am taking the 3 wedges that were shaded from 1/2 and the 2 wedges that were shaded from 1/3, and I am adding those parts together only. So that's the only thing you're going to add when we do these fractions. Okay, so let's take a look at an example. So I'm talking about 4/5 and 3/5. Okay, here's again kind of what I mean. I want to show you a picture representation of this. Okay, so let me grab my drawing tool. Okay, so here's my 4/5 and 3/5, and I'd like to add these together. So I'm going to say 4/5, okay, is kind of something like, again, this. Just pretend like these are all equal wedges. So I see now 5 wedges, right? And then 3/5 is also going to be 5 wedges. Okay. And so if I were to say, looking at this picture, how many wedges, how many equally sized wedges are put together? Well, here I'd say I have 4 of them. Okay. Here I'd say I have 3 of them. Okay. And so I would say my answer here is that there are 7 wedges that are shaded out of 5 that makes up a whole, right? So what that really means in this case is that we're going to have more than one whole wedge shaded, okay? Subtraction is going to be the same thing. I'm not going to change the denominator because I'm talking about whole circles or whole whatever that are in 10 parts. So 9/10 minus 7/10, I'm only going to subtract 9 minus 7, and I'm going to get 2/10. Okay? So our problem here says state your answer as a mixed number. So remember, 5 goes into 7 once, and there are 2 left over after that. Right? I have 5 wholes. Okay? So 1 2/5. This one I'm going to reduce it. Okay? 2 divided by 10. This is not a reduced fraction, and the standard is you should always reduce your fractions. We don't usually want to leave them in unreduced form. So 2 and 10 have a common multiple of 2. So I'm going to divide this by 2 and get a 1. I'm going to divide this by 2 and get a 5. So 1/5, okay, would be your equivalent fraction. Okay? So again, this is just a matter of practicing and remembering these rules. So in this example, same idea, except now my denominators are not the same. And again, what that would mean is that I'm really talking about whole objects that are not split into an equal number of parts, so we can't compare them. So I'm going to look at this and say I need common denominators. Okay, so the multiples of 10 are 10, 20, 30, etc. The multiples of 5 are 5, 10, 15. And I'm going to stop because there's 10 showing up on both lists. So 10 is the least common denominator. So I'm going to say this is going to stay the same, but this second one needs to have a denominator of 10. So to do that, I'm going to say 5 times 2 gives me 10. So 3 times 2 will give me a 6, right? So I did, in this case, times 2 times 2. That's how I changed it into an equivalent fraction. Now that I have common denominators, I can now put together these pieces and say, well, I have 3 out of 10 and 6 out of 10. 3 plus 6 gives me 9 out of 10. I'm going to stare at this real quick, 9/10, and make sure it does not have any common factors. 9 and 10 don't, so that is a reduced fraction. All right, I'm going to do the same thing now with 1/3 minus 2/7. The common denominator here, you can make the list if you'd like. I'm going to save myself a little bit of time and just say 21 is the least common one. Okay. So I want them both to have denominators of 21. Okay, because I can't compare them unless they do. Right, and now I'm going to say a subtraction in between them. That didn't change. And I'm going to say 3 turns into 21 by multiplying by 7. So this is a times 7. Right, that means this is times 7. So 1 times 7 is a 7. Okay, I'm going to do the same thing on the other side. 7 times 3 gives me 21. So 2 times 3 would give me a 6. Okay, so now I can subtract these. 7 minus 6 is 1. I am not going to touch the denominators. Okay, 1/21. Okay, and that is your common denominator. Okay, all right, last problems. So we're going to talk about mixed numbers. How can I add or subtract mixed numbers? And I want to give you a couple of different ways that you can do this. Okay, the first one says 4 and 2/5 plus 12 and 3/5, and we're going to talk about how do you add those together. So I'm going to show you kind of a slightly more straightforward way, and I think the slightly more straightforward way can be a little bit complicated. It can get a little bit complicated, so I want you to know about both. So the simplest way is going to be, if I put together the whole numbers, in this case 4 plus 12, I'm going to get 16 wholes, right? So remember, each of these, if you're thinking about our circles that we had back here, a 4 represents 4 completely shaded in circles, and 12 represents 12 completely shaded in circles. So when I'm saying 4 plus 12, I'm saying, well, yeah, there's 16 total completely shaded in circles. And then I have this little section of 2/5 and this little section of 3/5. I can add those together separately and say, hey, look, the denominators are the same, right? They both have 5s. So I can add across the numerators. 2 plus 3, well, that's 5 more. That's 5/5. Now, here's the problem. I can't leave it as 5/5, right? 5/5 is an improper fraction, right? Anything where the numerator is not smaller than the denominator, right? We don't leave those, right? So, for example, I'm not going to leave something as 7/5. I'm not going to leave something as 20/5, right? These all represent whole numbers that can get clumped in with this 16. So I'm not going to do these, okay? But if I had something like 4/5, I'd be good. So 5/5 represents 1 whole. So this is like 16. And then this 1 whole, this actually represents 17. Okay? So my answer here is 17. But you're going to have to go through and recognize equivalent fractions, that 5/5 represents 1 whole. And so instead of me writing 5/5, I'm going to clump that in. I'm going to like lump it in with the 16 and say there's 17 whole circles here. Okay? So that's one way of doing it. Here's the other way. The other way is to turn these into improper fractions and say, in this case, 5 times 4 is 20, 22/5. Okay? And then I can say 5 times 12 is 60, plus 3 is 63/5. Okay? Then in this form, I can say denominators are the same, so I'm allowed to add these together. Right? And now I'm going to say 22 plus 63 is 85/5. And by the way, 85/5, if you do 85 divided by 5, you're going to get 17. Okay? So you'll get to the same place, and it's just a matter of whether you're comfortable looking at something that looks like 16 and 5/5 and turning that into something that we would use like 17. Okay? So I'll show you again both methods in this one. Okay? So with this one, I can't put together the 1/3 and the 2/7, so I could do 8 minus 3. So let's do that. 8 minus 3 is 5. Okay? And then 1/3 minus 2/7, I have to do this now. So let's find out what happens here. Okay? So 3 and 7 we already seen in previous examples. 21's the common denominator here. Okay? So I'm going to say 3 times what gives me 21? Well, that's times 7. Okay? And so that means I'm also going to do this times 7. So that's 7 over 21. This is times 3. So I'm going to do also 2 times 3 and get a 6. So 7 21sts minus 6 21sts. Remember, subtract the numerators. Do not touch the denominators. That means 1 over 21 is left. And I can just attack that on right here. Okay? So that one worked out really nicely. Okay? The thing you got to be careful about here is sometimes if the second fraction's bigger and you end up with negatives, you kind of can't use that. If that were to happen, you can also, again, fall back to this. I'm going to show you the second strategy to get this as well. Right? You can also say, turn these into improper fractions. This is 24 plus 1. That's 25/3. Okay? This is 21 plus 2. Excuse me, that's 23/3, or 23/7. Okay? And then proceed through this problem. So again, do your common denominator of 21 here. Okay, but you can see this is not going to be all that nice anyway. It's going to be another kind of slightly more complex problem. So you have options here, and you want to choose whatever is easiest for you. Sometimes it's going to be easy to work with mixed numbers and subtracting. Sometimes it's going to be easier to work with mixed numbers. So I'm not going to finish this problem. I think you're capable of doing that. Okay, but again, the idea is, big idea, okay, find common denominators, add or subtract only across the numerator, right, so that we can talk about how many we have left of those little wedges that we talked about in the first example.